Now you're able to hear me? Yeah, I muted the call. Okay, so let it be on like that, huh? Let it be in this mode. Okay, fine. Okay.
Very good morning to one and all. On behalf of Aeronautical Engineering Department, I would like to welcome our chief guest, Dr. K.V. Srinivasan sir, scientist, ADE, DRDO, Bangalore. Our HOD sir, faculty friends, and my dear students. Let us start the session with a video tribute to our ever inspiration, Missile Man of India, Dr. APJ Abdul Kalam sir.
Hello? Any issue? What is the issue?
Around sir.
Are you able to hear me?
Yes sir, yes sir, yes sir.
But
2 minutes sir.
Okay, okay. So
It's
not from my
fine.
side.
So I'll yes sir, 2 minutes sir. I will welcome you. 2 minutes sir. Yes.
No problem, no problem. It's okay. I was just thinking. No problem.
I feel privileged and happy to welcome our head of the department, Mr. Gopinathan sir, to deliver the welcome address.
Thank you, sir. Am I audible to you all?
Yes sir.
How about are you able to see me, Mr. This one?
So you are audible sir. You are audible sir.
Yes, sir. Thank you.
You're not able to seeing me, no? Not seeing me.
No, your video is not available sir.
I have to put it
But
again.
we can hear you sir.
Now? I think.
It's a great pleasure to deliver the welcome address. First of all, I would like to convey my grateful to the management of Hindustan Education Institutions and our respected CEO sir and our respected guests to make this event possible today. The Department of Aeronautical Engineering and the Celebration Committee of Hindustan College of Engineering Technology associated with Jet Wings Bangalore and Bellatrix Aerospace Bangalore and TAS Academy celebrating the birthday of the Missile Man of India and ex-president of our country, the Bharat Ratna Dr. APJ Abdul Kalam. On this special occasion, on behalf of the Aeronautical Department, I heartily welcome our CEO sir to this event. Welcome you, sir. The next, I would like to convey my warm welcome to the Emeritus Scientist Dr. K.V. Srinivasan, Scientist G, Aeronautical Development Establishment, DRDO, Bangalore. Welcome you, sir.
Thank you.
Now I would like to convey my warm welcome to Mr. Main Ahmedullah Khan, Manager, the Ground Test Center, Rotary Wing Division, HAL, Bangalore. Welcome you, sir. I would like to extend my sincere welcome to all of my faculty members and all my dear students of Aeronautical Engineering Department for this great occasion. I welcome you all once again. Thank you. We have a great day ahead.
Thank you, sir. I would like to welcome Ms. Jodhimani of Chemistry Department to give away the introduction about our chief guest.
Am I audible, sir?
Yes, I'm able.
Yes, ma'am.
Thank you,
also.
sir. A very memorable moment to one and all gathered here. I feel immense pleasure to introduce our chief guest, KV Saravanan, Emeritus, KV Srinivasan, Emeritus Scientist, ADE DRDO, Bangalore. So first of all, a lot of thanks for accepting our request, sir, and
Hello.
being a part of this program. He is such a
One
unique
session.
person.
Huh? Yeah,
Sorry, sir. He is
okay.
such a unique person who has been equipped with good skills. He completed his BE Electrical from College of Engineering, Gindi, Madras University, Chennai, and also did his MTech Electrical Guidance and Control from IIT, Chennai. He served as a scientist for 36 years in DRDO and also acted as an emeritus scientist for 2 years at ADE. And he worked in the area of navigation, guidance, and control aspects of guided weapon system at DRDL Hyderabad, and later in the area of UAVS, that means flight control system and system engineering since 1982 at ADE Bangalore. He had more than 20 years of experience in the area of system integration and UAV field trials at ADE DRDO Bangalore. He acted as a member of governing council for Tamil Nadu government project on developing various types of UAVs for social applications in association with MIT Anna University Chennai. He published and presented several technical papers on UAVs in national and international seminar and conferences. He acted as a fellow of the Institution of Engineers and life member of Aeronautical Society of India and System Society of India, and a member of doctoral committee of Anna University and visiting faculty at MIT Chennai. He served as a reviewer of Journal of Aerospace Sciences and Technologies and Defense Science and Journal. He organized and conducted various international seminars and workshops with different international collaborations. Currently, he is a member of mobility team of RVCE Bangalore and also acted as a advisory board member of Aerospace Community Portal. And he is employed as a technical advisor at NDRF as an expert in the area of drones and actively involved in many civil drone projects and cyber project. Maybe this one day is inadequate to list out all those things. So on behalf of all, I feel very proud and welcome you, sir, to this wonderful program. Thank you, sir. Thank you so much, sir.
Thank you.
Thank you, ma'am. I would like to welcome Mr. Hariharan of Planet X Aerospace for this event. Welcome, Hariharan, sir. Sir, Srinivasan, sir, shall we start the program, sir?
Yes, you can flash my PPT.
Yes, sir.
Yeah,
Yes.
I can be able to see and then I can speak. Yes.
Okay. Students, the session is going to start now. I request students, if you have any questions, you can put it in the chat box so that it will be answered at the end of the session.
Can I start? Yeah.
Yes, sir.
Yeah. Good morning to you all. I'm very happy to be a part of this celebration of the birth anniversary of Dr. APJ Kalam. I'm very fortunate to work under him for nearly 10 years as part of the IGMTP program, as well as the under DRDO, another lab in DRDO, where he was our big boss. So I worked in the LCA Tejas program also. I contributed to the flyby flight control system. So I'm very fortunate to get this opportunity to speak on the celebration of the anniversary of Dr. APJ Kalam. So on the coming to the topic of UAVs, so today my topic will be a new UAVs and MAV, that is micro air vehicles, and UAVs also called drones. So a new focus in aeronautics. Why? Because now they are replacing all the roles of manned aircraft. Unmanned aerial vehicles, they are called. Now they are going to take over from manned aircraft and all the roles, the fighter, bombers, reconnaissance, any function, any role played by the manned aircraft can be played by the unmanned aerial vehicle. So that way, so a new focus has to be there. And then it's a very small in size. So low Ronald number aerodynamics. There are so many developments in the material side, engine side, avionics side, software, hardware. So, and also it is going to be applied in commercial and civil applications also. And then very miniature, even the insect the aerodynamics also people are studying now. That way a new focus has come in aeronautics, and many researchers are working in the area of UAVs. Many PhDs are being turned out. I am also guiding many researchers in the area of UAVs. So that way the UAVs has got a new focus in aeronautics. And let us go through the various slides to explain to you what is my intention of telling about this. Yeah, kindly next slide, please. So it is inspired by nature. If you all know that the bird is the first inspiration for the man to invent the aeroplane. So next, please. Next slide, please. Next slide. So 1933, we have to wait till 1933 to realize the dream of a man to fly like a bird. So this is the first bird that was produced by the Wright brothers. So and they started the program from 1933 onwards. Now there is 1903 onwards, and then there is no stop going to be there, and we can see the way all pervading this one. Man is now slave to the machines, and then wherever he wants to go, he can go in just a matter of few hours today. Yeah. Next slide, please. So what is UAV? So many of you would have known about UAV. UAVs are they're slightly bigger platforms where it is considered as a system of systems, where it is a aircraft without a pilot, an aircraft built around a payload. We need to carry a payload. Whereas in the civil aircraft, we call it passengers. Here it has to be a sensor and other things. And remotely from there are many different applications are increasing day by day, and today it's a very big industry. It is costing $100 billion today, and very cost effective. The main attraction is very cost effective. It is a cheaper alternative to manned aircraft, so that we can deploy it to any role produced by the manned aircraft. So it's very easy to produce a UAV compared to manned aircraft, and then you can produce in numbers. I can use it on anywhere in any place on the earth. And it's a valuable test bed for aeronautical research. So that way, it will add value to our aeronautical community also. Yeah, next please. Next, the father of manned aircraft is Wright brothers. The father of UAV is Mr. Langley, because even before Wright brothers invented the airplane, the manned flight. So in 1996, the first unpiloted engine-driven heavier than vehicle of substantial size were produced, and the name is called Aerodrome. So it flew for about 5 minutes. So it flew for 2 minutes until the fuel ran out, and then it the distance of about 1 kilometer at an altitude of about 35 meters at a speed of 20-25 kilometers. He was called the father of UAV because the first person who did the first unpiloted engine-driven heavier than air vehicle of substantial size. It's an unmanned vehicle. No pilot was there in the aircraft. Yes, please. Next. So why we need unmanned aerial vehicles compared to manned aircraft? So because it can do a job which manned aircraft cannot do. It can do a dull mission. That means it can perform for long hours. So many hours of operation is possible with a UAV. If you put the fuel or if you put the battery, it will charge very well, and we can go for hours together. One UAV sentry can cover the same area as 10 human sentries. So at the borders, etc., we can deploy it. It can do a dull mission. It keep on watching the borders. And it also give a dirty mission. That means investigate contaminated areas where the human being cannot go. It is very dangerous to human life. like a nuclear hazardous areas, etc. Sampling of hazardous materials, etc. You can do a dirty mission also, and then it can take up dangerous mission. Dangerous mission again, the riskier mission, they prosecute most defended targets where you cannot go at all. Heavily guarded, the anti-aircraft guns and all there. Missiles can go in the stealth mode. So very high risk areas also it can operate. So it can do a dull, dirty and dangerous mission. That is why it is better than manned air vehicle in many respects. That is why they prefer today the UAV roles more than unmanned, more than manned aircrafts. Yeah. Next, please. So if you see the UAVs, there are various types of UAVs available today. From few grams to few tons they are made actually. So over a period of time, since 1970s, the first Israeli, they deployed their UAVs against the Syrian military to destroy all their radars. So from that time onwards, there's no going back. And then we used the UAV extensively in the Iran-Iraq war. In the Iraq war, that's called the Operation Desert Storm. Afterward, in the Afghan war, now we can see the use of UAVs in various theaters of war. But it is useful for even research and other applications. Even the students can work in smaller sizes. So a few grams to few tons, we are able to produce UAVs and various shapes and sizes and various technology. You can see even a small UAV like few grams, we can produce and make it useful for to some mission or something like that. So you can see the short range UAV, micro UAV, mini UAV, tactical UAV, high altitude UAV, HAIL, we call it high altitude long endurance UAV. Then medium altitude long endurance UAV, and then finally UCAV. The UCAV is a combat aerial vehicle. Today, America is having a ship which is deployed in the South China Sea. So China is seeing a threat. From that ship, this UAV, the Boeing X-60, X-47, A-45 kind of shape, is a blended wing body UAV is taking off and landing. And it doesn't have any pilot. It can precisely bomb. It is a very stealth aircraft. And then it will come back in a short time. So all these UAVs are possible today, and we are able to produce many types of UAVs and use it for various purposes. So this is the military drones, what I have shown you. I will show you some more civil applications also. Yeah. Next, please. So you can see the various varieties and shapes. So the VTOL UAV, it can take off vertically. You don't need a runway at all. So you can have a small launcher or a vertical launch also possible. So canard rotor UAV, tilt rotor UAV, which are all not possible in the manned aircraft kind of configurations. So UAV got a very special configuration, and you can produce in different ways and can understand the aeronautics. So people who want to enjoy aeronautics, this is a way to enter. The UAV is a better way to approach aeronautics, and you can understand how it functions. The tail sitter, ducted fan, helicopter, then gyroplane, tilt body. So various concepts can be experimented and will be very good test bed for aeronautical research. Yeah, kindly next one, please. So the other one is the smallest, even insect can be simulated using this one, the UAV technology. You can see a cyborg, which is nothing but a mechanism being both biological and artificial. Electronic mechanism. So the term coined by 1960 by Mr. Norton and Klein. So you can see that the small cyborg, which can be used for even disaster management kind of application, etc., where the building collapse has taken place, nobody can go and see where the polymers as their wings, and then the small actuators, then microorganism, the landing mechanism, bacterial adoption, coded wings, etc. All are artificial. This is not real one, but you can produce a cyborg and then make use of them on special applications area. Yeah, it has got different types of guidance and control also. Yeah, definitely. Yes. Now, see the missions, UAV missions. Now, because we can produce in various varieties and different sizes, it can be applied for many roles which manned aircraft cannot be readily used. So disaster management is a very, very important application for UAVs in the case of fire, floods, earthquake, landslide, gas leaks, search and rescue, etc. Our MIT Anna University, if you have seen Anna University, they have already applied their UAVs for some of these applications. Yeah, they have applied already, and then even the present corona pandemic they have used for spraying the disinfectant chemicals, even the monitoring of the people who are having infection, etc. And of course, defense and security applications are surveillance, reconnaissance, communication relay, electronic warfare, nuclear, biological, chemical detection, explosive detection, riot control, crowd monitoring, and traffic control, and it is unlimited. Actually, the number of roles are going to be unlimited, and then it can have a commercial application also for photography. Even the film people are going to use, film industry people are going to use it, and television, cinema, agriculture. It's a major use is there right now. Precision agriculture now everywhere all over the world they are trying to use for agriculture and on mapping kind of application. And then you can use it as an R&D tool also, evaluation of new concepts. So that way the UAV has got variety of roles and then variety of sizes, variety of shape, and then a lot of challenge to aerodynamics people, and it will be a valuable test bed for even research. Yeah, next please. So here is the military kind of mission I have depicted. So here military, they started with the military applications only, all the UAVs, the reconnaissance and surveillance. So on the border now all these things are deployed. Today the war, now before the war can start, all the UAVs will feed the information. So without the UAVs, definitely you cannot win the war today. So definitely UAVs are very, very important assets in the warfare today, military warfare. America is deployed 24/7, so many UAVs across various countries, and they are able to spy and get all the information. Whatever happening in the world, they know already. So they have got their Predators and their Global Hawk UAVs, which is already flying at a very high altitudes, and then able to get all the information they want, so that they can launch their attacks anytime. So reconnaissance, surveillance, target acquisition, communication relay, search and rescue, electronic warfare, battle management, etc. So all these kind of roles are there, which is required for military application, and then it is replacing manned aircraft. So very cheaper alternative to manned aircraft, and they are able to save a lot of money, and then now produce in numbers etc. today. Yeah, next please. And the civil application, we can see the various applications in the case of fire detection, then the pollution detection. This is the smoke billowing out of the chimney of the power plant, and the flood affection. Then traffic monitoring. You can see the traffic monitoring. Also, you can see the aerial mapping, and then the pipeline monitoring. Like that, there are so many applications. It is ever growing. Today, we have got applications of civil applications increasing day by day, and then many startups have come in this area. Many people are able to give services of UAVs for various applications, civil and commercial. Yeah, please go ahead. Next. So commercial application means asset monitoring. So here where they are giving services and they can earn money also. Many startups can do all this, giving a service. So they can get deployed for agriculture, land management, resource management, monitoring, railway line monitoring, etc. So anything you can, any role you can think of, you can put a UAV there. So UAVs are very handy today, and then you can have many applications. It is possible. So it is a very good field of the entry for any startup kind of ideas, and many engineers can work. It's a multidisciplinary team is required for this. So it doesn't, it's not restricted only aeronautics, mechanical. All people can enter this area and then work, and then gain knowledge. Yeah, next please. So this is one application where the American police, they are using it. So definitely the America is a very huge country, and then they need a lot of police and things like that. So the police are taking the help of UAVs there, a small quadrilateral UAV there. So aerially it is able to track the person who is stealing certain things, etc. And then they are able to track down and pin him down, and then they are able to catch him in no time. So helicopter law enforcement is in a very big application there. Even in the prison areas there, the UAVs are being used, so that the people are monitoring whether they are escaping or something like that. So always the police is using the UAVs in their environment. It's very important for them. Yeah, next. And used for power line inspection. Some of these European nations and some other nations they are already using it for power line monitoring, because without interrupting the power, we can do cleaning of these insulators, as well as we can see whether any cracks are there in the power line, any other problems are there. So inspections can be done so that the safety of the power line can be ensured. So this is one of the important applications there. Yes, next please. So similarly, search and rescue. So there are in winter in Europe, there are many people go for skiing, etc. In Europe. So the Alps mountain, etc. So here some people can be missing. So you want to see the missing person, some type of UAV can be deployed for rescuing them. So during avalanche and things like that, even the people climbing Himalayas, the avalanche takes place and many people go missing. So if you want to use UAV, this is a very good application, and they have already thought of using it in the European area. Yeah, next please. So in Russia, this is in Russia where many demonstrations take place, and many countries you can see that at many instances you can look. I mean, the crowd can be monitored. So even MIT Anna University has done this kind of use for Tiruvannamalai Deepam. They are already using it. Their UAVs are being used for monitoring the crowd. For crowd monitoring as well as the media coverage, you can use UAVs using different types of cameras. Yeah, next please. So this is another important this thing information I want to give you. So in America, the company has got a patent. So the small UAVs, the battery, this thing is limited. The endurance of the UAV is limited because of the batteries. More than 60 to 90 minutes, we cannot fly there. So you want to give a charge to the battery, it is possible without bringing it down. So here there's a small vehicle fitted with a laser, laser source. So laser source can aim at the UAV and then give power, transfer the power to the UAV and charge the batteries. So that's why it's a very, very useful application. So people can think of it in our applications also without bringing down the UAV while they're flying in air, like aerial refueling for manned aircraft. This is nothing but a aerial charging of the batteries while the UAVs are flying. So this is a very good application, and our people also, we can start thinking in this direction. Already America is some company has got a patent for this. Yes, next one please. So you can see there are a variety of applications, and then all these things require a lot of variety of unconventional configuration. People have to think and then do variety of calculations in aerodynamics, and then wind tunnel testing, and then a lot of calculations, and then material testing, then fabrication, and all different kinds of materials, etc. So it throws a lot of challenge for the engineers actually. So for engineering community, because it's a large variety and unconventional configuration, so you don't have even thought of it. So manned aircraft means everybody knows that wing and tail, how it has to be arranged, etc. Whereas UAV, you cannot say. It can be very peculiar. It can be very different from manned aircraft configuration. That itself gives a very good challenge for the aeronautic students. And then wide range of speed and then flight envelope. So it is compared to the manned aircraft where things are all limited. It can be very unlimited. It can fly from very low altitude to very high altitude. So the unsteady Reynolds number, all the low Reynolds number, unsteady flows are all there. So very difficult to analyze. And the CFDs are all new codes are being generated to study all this problem. So I was involved in some of these studies, and then it's very challenging for even the aeronautical engineers to have a CFD code developed for this kind of application. Then lightweight composites and new smart materials for airframe. So we have got smart materials are being used for UAV kind of application. So it is triggering a lot of development in even materials also. And some of these UAVs can be highly maneuverable. Manned aircraft is limited by the man sitting in the aircraft. That is about more than 6 to 8 G you cannot pull. Whereas high maneuverability aircraft can be designed. UAV can be designed even more than 8 G, 10 G, 20 G also you can go. If you have a proper material and proper engine, if you have, we can go for any kind of GS, etc. And it can go for VTOL, very, very vertical takeoff landing, thrust vector control, damage tolerance, materials, collision avoidance. So many features can be incorporated. It's a challenge. So also it is like unmanned aircraft where very limited variety is there, whereas the variety is enormous in place of UAVs. So variety of propulsion systems are being used. Even fuel cells are being used. Batteries are used, mostly electrical batteries. Electrical motors are used. Then small engines also being developed. No, diesel engines are being developed in Germany, etc. For so depending upon the size of the miniature electronics were big there. It is going smaller and smaller. Then multifunctional integration, etc. So advanced navigation guidance techniques, which is not heard of in even manned aircraft scenario. Highly integrated data links and jam-proof communication. One important thing is UAV said there is no man sitting in the aircraft, so it has to be commanded from the ground, or it has to be remotely commanded. So definitely you need a data link, very powerful data links, different kinds of frequencies, and jam-proof communication, because somebody cannot take over. You would have heard about that Iran has hijacked the American UAV and then taken over, and then announced to the world that we are able to, even the stealth UAV from USA, we are able to hack it using the GPS. That is a weak link. So we need to have a proper jam-proof communication, and then jam-proof GPS and things like that for the UAV. So it throws a lot of challenges for even the electronics and avionics engineer. And miniaturized payloads and smart munition. It can carry even weapons also. It can attack any small area or big area, etc., depending on the payload. And miniaturized payload means a variety of sensors, thermal sensor, cameras, and then all kinds of sensors, electronic intelligence, communication intelligence. So many payloads are there. This itself is a billion-dollar industry. Today, Israel is one of the biggest, UAV, industry it has got in the world. In more than America, because Israel supplies UAV to all over the world. America doesn't give UAVs to everybody, whereas Israelis are selling everywhere. And then the payload industry is the very biggest in UAV. I visited Israel in three, 4 times. I have seen that payload industry is very big. And then they are supplying even to American UAVs. So Israelis are supplying to all over the world, including America. So their payloads are very good, and there's a variety of payloads, and it's a very billion-dollar industry for them. So definitely it's a very good opportunity for anybody to invest in this area and then start working. And even within civil airspace, the new regulatory issues. Now we can see the DGCA is trying to bring different kind of regulation, because it should not be a nuisance for public, and wherever the public assets or their properties are there, and the ethical issues also there. But Ashish Bhatt is a person who has become a student and become an entrepreneur. He started his career at IIT Bombay, and then he learned everything through a DRDO project and became an entrepreneur. And Idea Forge is a company in Mumbai. Now he's having a few crores turnover now. He's able to sell so many UAVs to defense and border security today. Yeah. Next one is MIT Anna University. So,
yes, sir. So the next video is going to be about our MIT Daksha team video.
That's right. Chantal. Next, you can play the morphing UAV. That is, skip that Coanda effect. You can play morphing UAV first.
Okay, sir. Okay.
This the NASA Puffin, is it? This is a long endurance. I mean, 2 minutes. You can cut short whenever you want. You put this. Okay, this is a personal air vehicle. Yeah, this is called. So people can go to office using this when there is a traffic jam. That has been envisaged in many cities. This is a practical thing. Yeah. Okay, this is your show. Yeah, you please play this morphing you. Where the shape memory alloys, which can change the shape of the wings. In flight, we can change the wing shape. These are all possible today. There will be funny. Yeah, next we can show the
Now I'll play the NASA videos. NASA Puffin.
NASA would kindly do it. Fine. You can cut short the time is running away, running into others person time. You can depend upon your time knowledge.
Okay, sir. Okay.
Is a VTO UAV. You can just fast forward to some extent where you can see the person. A little fast forward. You can little play at normal speed. You can see the person there who is going to office. Is a fuel cell based UAV where endurance is. You can see the person standing there. He's got a small bag to the office. It's carrying. So tail sitter configuration. Vertical takeoff. Then you can go horizontal. You can go a little fast. So it doesn't need a runway. You see the person there. So he can fly and land wherever he wants on top of buildings. Then he'll come back in the evening and land. This is a personal air vehicle concept. So this is envisaged in many cities in this kind of a role. Yeah. Next one you can play if you want to have time. If you have time. Honda effect. Ducted fan baby.
Yes, sir. I play that video, sir. Yes.
Okay. If you have,
Yes. Yes.
the 1 minute. So you can see like UFO. It is like a UFO. It is nothing but a ducted fan UAV. Ducted fan. So this is harmless and very safe to handle. So Honeywell has produced a UAV like this. Honeywell has given to Army, US Army, and similar kind of UAV they have got. Honeywell. So you can see the control surface and all. The ducted fan is there. This can go between buildings and things like that. So aerodynamics is so different. Yeah. So in Belgaum, India also, one person has produced UAV like this. One person in India also. It's already in the news. So you can see a variety of possibilities in UAV technology. Is able to touch the UAV. Very slow and it's autonomous systems.
Yes, sir. Thank you, sir.
Welcome.
Students, you can post the question. I have got few questions. Sir, shall we go for the questions? Sir?
Yes, please.
Yes, sir.
I'll have to watch and answer. Is it something like that?
No, I'll help you out, sir.
Okay, fine. Tell me. Yes.
So there is a question: what are the steps taken for aviation field to develop evolution of drones in space? Is there a possibility to develop drones for space?
Definitely, there's a need and there is a this is growing, but they have not developed it like the aeronautics field. Definitely, space people also require different kinds of application, definitely in different environment. So that's what will happen. Some people in USA they started working off for drones in operating in Mars atmosphere, operating in moon atmosphere, etc. Definitely, you need to have a different types of drones even for those kind of application. Definitely, so that is not started in a big way, but they have started in the rover design and all other kinds of thing applications. And in different UAV components are being used. We have helped them in their RLV design. That's called reusable launch vehicle, no, for their launch vehicle. So they want to take off like a space shuttle. For that, UAV concept are big. They use like a UAV actually. The RLV design we call reusable launch vehicle. They wanted to take a man to the moon and then release that schedule. Then space shuttle will come back. Things like that. So that's kind of a things started in a big way, but it is yet to pick up for the space industry. But imaging kind of things and all can be done. They can do the imaging kind of applications and all. The space department can help all the thing whatever they want, but they are not applied like the aviation other industry. Definitely civil aviation industry or military aircraft industry. They are not applied drones. Definitely, it's a possibilities are there. Yes, please.
Okay, sir. So then one more question: should we need to focus more on fighter jets or UAV?
No, only UAVs because America is going to stop working on that. So America's funding has reduced. Every other country, definitely, the war itself is a nuisance thing. Definitely, nobody will win a war. Definitely, will destroy each other. So war is not the way to go. So UAVs for various applications, civil and commercial applications, that is the way to go. And definitely, it is worthwhile, and everybody will appreciate that kind of application. So fighter aircraft definitely not the way to go. Definitely, we should not develop various fighter aircraft. Only in America and big countries, they will invest a lot of money and then waste their money and then whatever war will kill each other only. That's not. It is not a healthy kind of a situation. So people don't want wars, isn't it, in future? So gradually, it is coming down, but people want to say that they are strong. That's what to show that it's called deterrent. We call it. We have Agni missile, but definitely we don't want to use it. Agni missile is as a deterrent only. Same thing, other aircrafts all they will make and keep it, but very rarely they will use it actually. So right now there's a war situation is there, but gradually the people will support peace only, not the war. Definitely, yeah.
Sir, there is one.
UAVs are better. Better to work on UAVs. That is the way to go.
Yes, sir. Thank you, sir. There is one question, sir. Actually, in our institution, sir, we have different teams. As you mentioned, about MIT, we have different teams working for drones for different application.
That's correct.
The problem that we currently face is that importing the components from other countries, especially China. So that is a question. This due to the problem, the cost of each and every part is increased. So is there a possibility to manufacture all those?
In fact, DC enterprises in Bangalore, they are making different kinds of motors, brushless DC motors. So definitely, the motors are already being made in India, different kind of small motors, servo motors, etc. So and then airframe is not an issue at all. So electronics also, it is possible. Now Sendil is getting it done in India itself, most of the electronics. So unless it is very, very small size, where we don't have fabrication facility, semiconductor fabrication, that is the only limitation. Very small size electronics, we cannot do it. So it has to be done from Taiwan. So we can avoid China, but Taiwan is a friendly country. We can get it from Taiwan. And some other France or some other European countries you can get. There's alternate sources available today, apart from China. Definitely we can get it. There are many countries selling this item other than China also available today in the market. But once the Chinese market goes, they will also bring down the prices actually, because numbers are more now. Definitely, many people will hobby. It's very good in this UAV, the small market. Toy market, they are very good. All the small components are being made. In fact, America is getting most of the things done by Mexico, because it's cottage industry now. The 3D robotics company, 3D robotics, Parrot aircraft system, and the Chinese, DJI. These are the three major in drone industries. Now the DJI will go now. Nobody wants DJI. So the Parrot systems and 3D robotics will gain importance, and many people can buy from them. 3D robotics is supplying all kinds of items. They are getting it done by Mexico people, basically. They are helping them, definitely. All the small components. It is available. You can get it.
Yeah. Yes, sir. So, is there any drone that is used to monitor the space station? There is one more question, sir.
Space station, is it?
Yes, sir.
As my knowledge goes, there is no drone to monitor. Definitely, there is no drone, because the space station, definitely being that altitude, you need to have a special kind of drone for that actually. So definitely we don't have drones with that kind of engine actually. Only Global Hawk, which is operating at about 1 lakh feet, that is 100,000 feet. It is operating today in the world. Okay, those drones now, we got special engines they have got. So it has to go beyond that height, definitely. So we don't have engines, drones with that kind of engine there. Definitely, it is not there right now. Yes, only.
Sorry, the question is, the student is asking, is it possible? Can we work on that?
Yes, it is possible. Definitely. So definitely ionic propulsion. So we have got different kinds of propulsion today. People are working on that, definitely. You will have company, definitely. There is not that you are not the first person to work it. Now there are many people are working on this kind of propulsion system. Yes, already people have thought of it. So that's what there are people in many companies are, many people are designing drones for even other planets, how the drones will work there. People have started working on that. And then even space drones also possible. We have engines to take you to even beyond that altitude, beyond the stratosphere and things like that. So you will have in future all these things. Definitely you can try, think of working in this area. Definitely it's worthwhile. You can explore all these things. Definitely. Yes.
Yes, sir. From my side, I have a question, sir. Whether how to we have skilled students in terms of developing a drones. Even we do fixed wing drones also.
That's correct. Okay.
UAV.
Okay.
So how to connect with the government agencies like DRDO, AD, etc. How to connect with them, sir? Is there any whether DRDO are giving a chance opportunity for students to do some kind of work?
Now Satish Reddy, he gave a talk. Now he so he wants to encourage anybody who wants to work for defense. Definitely, what you do is you can contact the DRDO Bhavan. Satish Reddy is there. His PA or somebody you can contact. So definitely he is ready to give. They're having instead a startup fund. So he is going to put some money as a startup fund. People can make use of it. And then you have to tell your application, definitely, what do you want to do for the defense, definitely. Otherwise, one way is going to do is through AR&DB. So AR&DB, there's a UAV panel started now. We used to work for a small panel there, system. It's called Sigma panel of R&D. DRD, we are all members there. Mr. Krishnan, the director of ADE, he was the chairman of that thing. Now he is still continuing as a chairman. Now that Sigma panel has become UAV panel. So the defense want various kind of UAVs. Definitely they encourage the entrepreneurs and the private people to enter. So Satish Reddy has got some ideas and already going to fund all these kind of ventures definitely. But through AR&DB, there is always a possibility. AR&DB, there's a panel, Aeronautical Research and Development Board is there, funded, DRD funded. So you can apply for that. You can, in fact, we have encouraged many colleges in Tamil Nadu also. They have made some different kinds of applications and things like that, UAV-based applications. You can try that through AR&DB first. You can get a small project. 10 lakhs minimum is no problem, they will give you. If you want more money, crores, you will not get it so easily. So 10 or 20 lakhs easy to get from them with an application and things like that. Defense-oriented application. Many people are doing it actually. Already AR&DB, I have got many UAV projects already done. So definitely you can apply through that. And Satish Reddy is the person to approach. He has already announced in the recent webinar. He told that they want to fund all the startups. It's possible today. Yes.
Yes, sir. Thank you, sir. So I request Mr. Guru Prasad, number 23. Guru Prasad, can you unmute and ask the question, because you are mentioning a regular transmitter. I don't know exactly which transmitter you are asking, so that you can directly ask our guest.
Yes, please.
Guru Prasad. Sir, the student is asking question that whether why can't a regular transmitter have a good penetration in terms of connectivity? It normally can't penetrate walls. Why, sir? That is a question. So I don't know which transmitter is using it. So I think he's not available currently on the call.
Which transmitter is being?
Why can't a regular transmitter have good penetration in terms of connectivity?
For this kind of application, because the frequency, for UAV, frequencies, normal frequencies are not allowed actually. So definitely it will interfere with the other communications, ship to ship based communication, because aircrafts are flying, etc. So definitely the separate band is allocated actually for UAV operations. So definitely you cannot use the common frequency which is used in the commercial field. Like various agencies are using different kinds of frequencies to be allocated. There's a particular, the communication ministry, they will allocate the band definitely for this. Even DRDO, we ask for a particular band. Even for military satellites also, they are going to operate, give a band for communicating with our UAVs, etc. We are going to have dedicated satellites for UAVs in India. So definitely we have our own band of frequencies for that, etc. So we cannot interfere with the other frequencies already existing by the Post and Telegraph Department, then the ship communications, then the airborne to ATC communication. There are so many communication, so many people are operating. The data they are sending, companies and all the IT companies are using. So definitely it's a sensitive issue. So you cannot use regular transmitters for this kind of application. Definitely, yes.
So there is another final question, general question from our students. Many of them have asked it. Correct. Why in our country we are restricted in using transportation, that is to deliver products or to deliver organs? Why there is restrictions comparing other countries?
No. Even America, there are a lot of objections there. FAA now selectively they have given license for some companies now selectively. So these people have to prove that their onboard electronics is very safe and it will not collide with any other one. That's called collision avoidance feature should be there. Collision avoidance, okay. That is one of the important features. You should demonstrate the collision avoidance feature. So the onboard autopilot is not just enough to fly. So you should have some safety features. If you put safety features and demonstrate to the people, definitely DGCA also will give permission. So definitely you should not hit a building, you should not hit a communication tower. Okay, you should not go and fall in a particular place. So what they are telling is you should have a small parachute to recover. So your drones that's what Chandil is already doing it now. So all drones should have a small parachute and have collision avoidance system. Okay, and then you should not, it should communicate to the ATC. Suppose if you are going near the airport area, you should talk to the ATC. The drone operator should be able to communicate to ATC and you should talk through the drone. So all this communication system should be installed. So some extra electronic features are required to be put in the drone. Then it is possible to operate. So those features are already in American UAVs. They are already put now. Some of these UAVs, which are all given permission, they have all these features. Like they are all what is it? This Collins, no, Collins Aerospace, Rockwell Collins. They are having this kind of features actually. Rockwell Collins, they have designed autopilots and all with this kind of features for UAVs, and they're all being used. So if you have a special autopilot with all these features and special communication system, you can also operate and they will give permission. So you have to demonstrate that it's a safety and it will not collide with any other object space. That's what is a requirement. Yeah.
Yes, sir. So thank you, sir. Thank you so much, sir. We are very much happy, and it is we are indeed pleasure in listening to you. And
Thank you.
the time we have spent with you is remember always will be in our mind, sir.
Thank you.
So I will, on behalf of Aeronautical Engineering Department, Hindustan College of Engineering and Technology, once again I extend my warm thank to you, sir.
Thank you.
I also like to thank Moin Ahmadullah Khan for helping
great.
us in bringing you to us to encourage our students. Sir, soon we are going to develop a laboratory, state of the art.
Sure. I'll be of any help to you. Definitely, please call me or can talk to me, and then
Definitely.
I'll be able to of any help to you. No problem. I'll be available. Definitely, you can call me. Definitely.
Yes,
Through
sir.
Mr. Moin Khan also, you can contact me. We'll all be of any help, whatever you want. Definitely.
It will be great if you can come and wish us personally,
Sure.
sir.
We'll do that. So sometime we'll do that. Okay. Kindly.
Yes.
Yeah. Thank you very much for the opportunity given.
Thank you, sir.
So,
Thank you.
sorry to have taken Moin's time. Okay,
Thank you, sir.
let him
Thank
start.
you so much.
Okay.
Thank you so much, sir. Thank you, sir.
Welcome. Thank you.
So, students, the next session will start by 12:40. So, I request all the students to join for the next section by 12:40. Sir, Moin Abdullah Khan, sir.
Yeah.
Ahmadullah Khan, available,
Yeah.
sir. Sir, we'll start the next session by 12:40 in the same link itself, sir.
Yeah, I'm available. Yeah.
Yes, sir. Yes, sir. Thank you, sir.
Then induction of Rafale was an festive event for us. We had inducted Rafale aircraft into Indian Air Force and successfully firing of BrahMos from Sukhoi 30 aircraft. That integration also carried out by HAL and test trials also carried out, and it is successfully proven. Indian Navy requires nearly 200 naval helicopters. ALH naval version, we had developed a tail boom folding project. Okay, it can be why, because when helicopter is landed on the deck of the marine ship, it has a space challenge. Folding facility, more helicopters can be accommodated. Indian Air Force requires trainer aircrafts and frontline fighters, and we already have so many aged aircrafts with us, like MiG, okay, and Mirage. We have these are all aged aircraft. So all this need to be replaced in all the squadrons. And when we come to helicopters, we have Cheetah, Chetak. These are almost like 30 to 40 years. That is how, whenever we talk about Indian defense market in the world, you see either it is a US, either it is Israel, either France, either Germany, Russia, they all run down to India to join hands with us, to sign MOUs with us, to come into joint collaboration activities with us. Why? Because we got a potential market. We are doing good by indigenization also, but still the market is so open that each and every MNC is there in India today, and particularly in Bangalore. If you take Bangalore, you take Airbus, Boeing, Rolls-Royce, Safran, any company you name, those offices are there in Bangalore. That's why Bangalore is called as aviation hub of India. Okay. MNC projects, let us see some MNC projects. Dynamic Technologies is the company. They are booming with a lot of projects. They are into world-class manufacturing setup they have, and they are developing. They are already partnered with Airbus and Boeing and Bell Helicopter and their manufacturing structures. Mahindra Aerostructures. Many of you may not be knowing that Mahindra company, which is into automotive, they are into aerostructures also, and they had developed. They are collaborated with many companies and developing components for aircraft structures. Even they had developed an aircraft also in a foreign collaboration. And Boeing entered partnership with Mahindra Defense Systems and HAL to manufacture F-18 Super Hornet fighter aircrafts in India. L&T, many of you may not be knowing L&T. L&T is also a big player. They are into indigenization and design and development solutions. They're mainly working on control solutions, weapon guidance, weapon integration. So one company had taken one field as their niche field, and they're doing their caliber. They're showing their caliber. Okay, and here even at shipyard at Chennai, they are doing some great work. Wipro company, which we see Azim Premji sir. Wipro is in software also and household electronics and electronics. They are into manufacturing as well. Their manufacturing plant at Pinya, Bangalore, it is very big, and they are into aerospace sector, mainly looking into aircraft structures as well as propulsion components. They are doing 3D printing and metal sintering, laser metal processing, and 3D printing of aircraft engine systems like turbines, compressors, shafts. They had very good facility in Bangalore, and they are in hands together with the Israel aerospace industry for a strategic alliance for composite structures and for even for UAVs. Adani Group. Nowadays, you may be aware that much from the Gujarat-based organizations like Adani, then Ambani-based Reliance, and all those things companies are progressing in the aero field. Adani Group aggressively eyeing on aerospace and defense projects, and they had even done and tie up with Alpha Design Technologies. Alpha Design Technologies is also Bangalore-based. I know very good people there, and they combinedly are into development of drones, helicopters, simulators, and Adani Defense is working along with Israel Elbit Systems also to develop drones in India. Tata Aerospace and Defense, Tata Technologies you take, and Tata Advanced Materials, they have another one, this one, and Tata Advanced Systems, they are another group. So Tata is also eyeing a very big projects, and in fact they had taken some already Dornier aircraft and some projects, and doing some joint collaboration, and they are working on it. So Tata is also a frontline competitor in the aerospace field. Some of the technological domains which you should think, that is artificial intelligence. Whenever we are talking about aircraft, as I mentioned, aircraft is a tough technology. You just think about a bike. You are riding a bike, being it's a mechanical design and automotive design, you depends on high-end electronics, speedometers, a quick starter, and some electronic gadgets, even in the automotive car industry. So likewise, when you go for aircraft, it is a robust where you depends on computer science, you depends on civil engineering, you depends on electrical, electronics. So that's why all these papers are integrated in your engineering. Many of you may be thinking, why I'm reading this? When those guys are not reading, my aerodynamics or some papers, why I'm reading this? Because as an aeronautical engineer, you should have a hand above all these technologies, and you should integrate and implement all these technologies in order to make the flying objects. Okay, that's why your knowledge is far better compared with any other departmental people. Why? Because the expertise lies in taking other domains, accepting it, and reading those domains and implementing those technologies. Some of the technologies are like artificial intelligence. Today, any activity you take in industry, it mainly driven by artificial intelligence. It mainly driven by computing, cloud computing, mathematical modeling, so simulations. So most of these are we are getting into new era. So artificial intelligence is one area. Robotic machinery reduce a lot of manpower times and achieve greater speed in the projects. Then 3D printing technology is well accepted by the industry. Why? Because when we are going for R&D projects and to make prototype models, 3D printing will help us in reducing time and wastage of material. Then precision tools. Nowadays, there are so many precision and digital tools to measure and to analyze whatever we do. Then weapon guidance systems. I put a weapon, but normally it can be a guidance systems. So you take helicopter or aircraft or any technology, there should be a lot of systems should be involved, and systems should have required for even testing, ground testing, flight testing, and all those activities. That's how systems and controls also. And advanced manufacturing. Whatever we are seeing today is getting much more advanced. They are involving into kind of computer based, technology based, electronics based manufacturing systems. So we should all aware about advanced manufacturing systems also. This is a brief. Before I get into the main thing, you should know that India is progressing and rapidly progressing. We are getting into a fighter mode with all the international companies, and day by day we are progressing in developing new tools and technologies. I will come into another PPT. Yeah. Okay, guys. So we know that there are so many projects, and we know that we are studying aeronautical and aerospace engineering. So where is the real gap? People say there is an industry gap. There is an industry gap. We need to calculate now what is that gap and where it is actually. Unless you understand this, you will not be able to link yourself with the industry. And another thing is, you will see there are no job opportunities outside. Even before pandemic also, there was a situation that aeronautical engineers are facing problem in getting placements. What is the main cause? Aeronautical engineering, as I said, it's a study of complex systems and so many technologies. But as an aeronautical engineer, you focus on your area of interest. want somebody to, for example, you had been taken into Airbus. They want you to take care of production line. Okay, and you will say, no, sir, I am not having production knowledge. But he want an aeronautical engineer to take care of the production line. He want an aeronautical engineer to take care of quality line. One he that's why the company is not qualified. Once you take out from your mind and once you are open, yes, I can take up any kind of job related with an aircraft, then you can see that more vacancies is not and some jobs are there, but it is our mindset. We are lagging. Okay. Aeronautics. Aeronautics is a Greek word, okay, and it's a mixture of two words: air, air. It is means like surrounding fluid, air, and nautica. Okay, navigation of the air. The ones who controls or once you study about the navigation. Okay, aeronautical and aerospace engineers are professionals who use science and technology to design, develop, test new technologies for making capable machines which can fly in air. Okay, for example, you made a drone and it is not flying in air, and you cannot be called as an aeronautical engineer. Just an example. You should make something which can be a flyable object. Okay, those machines are much useful in civil, military, R&D applications and for space explorations. And again, I am coming to that. When I am telling that you should be a part of a flying mission. You should be a part of a flying component making mission. Okay, and so even you help them in developing some systems, subsystems. You are part of the project. Okay, so civil, military, R&D applications and space explorations. Career paths. Okay, we'll talk how it is. Being an aeronautical and aerospace engineer, these are your job domains. First, you should know where and all you are eligible, which and all jobs you can take. That you should know. One is my first choice is academicians. Academicians means professors, assistant professors, lecturers. Okay, somebody will say, sir, I am much interested in teaching field. For them, the doors are much wider open. You can complete your BTech, you can complete your MTech, you can do PhD. You can get into not only private colleges, you can get into IISc, IITs, NITs. There are so many premier institutes in this country, and they pay a good package, and their labs are very highly, sophisticated. You can get into the labs and do so many R&D projects in association with big labs of this country. Okay, so academicians, even academician or even professor or lecturership is a great career path. Okay, then next you can be a design engineer. Okay, you can design components, you can design systems, you can design flying objects. Okay, production engineers, you can be a production engineer. So to being a production engineer, you should read good strength of materials, you should read mechanics of machines, kinematics of machines, production papers, QA, quality assurance papers. Your knowledge, you should put your focus on production engineers, production engineering concepts also. Manufacturing specialist. Once you are doing batch production, you are going for a large scale manufacturing units. So you should have a full-fledged manufacturing setup, working knowledge, or those kind of subjects also. You can choose and you can get into the job. Then material engineers, specialists. However, there is a separate branch for material engineering. Your knowledge on composites, smart materials, as well as aircraft structures, light aircraft material, and these are places where they really require aero engineer to take a decision. So your knowledge on aircraft materials or material engineering should be good enough, and there is an area for job vacancy. aircraft systems and subsystems, quality assurance engineers, test engineers. I am a test engineer. So any of, for example, a helicopter we are making, we should test it first in the ground, whether all the systems are properly working. If everything is okay, then only it will go for a flight test. When we are talking about ground test can be for a period of 6 months to 1 year. It is not like just for 1 hour before you are doing and it is going to fly. No, it is not like that. Each and every component, if there are 20,000 components in a helicopter, each and every component need to be tested for its vibration, temperatures, performance, and smooth functioning, and all together integrated as a model, its structural behavior. All those things we need to test it. Once everything is tested on the ground, once we are okay, then only it will go for a flight. Again, it has to go for so many numerous hours of flight testing. First he will take off and land, then he will go little heighter, then he will steep, then he will go cruising, landing, aerobatic performance. So even in the flights they will take a number of tests. Then operations, when it go for real-time operations, then also you have to monitor it properly. Okay. Then assembly managers, individual components are manufactured, you need to be an assembly manager to assemble it, and you need to see the progress of the project. Then flight dispatchers, once assembly is done, it's your responsibility to dispatch it until hand over it to the pilot by checking all the routine checkups as well as the assembly activity what it has carried out. Performance engineers, they perform like how many flights are happening, how collecting the data, analyzing the data, and putting the plots and all those things. Then pilots, you can be a pilot also. You can be a pilot when I'm talking, you can be a pilot for aircraft, helicopter, drone pilot also. You can sit as a control place, control center, and through laptop you can fly in drone also. And nowadays there are so many space missions where human interference is required. Human as a pilot need to be astronaut, you call it. So you need to get it. Maintenance engineers, once aircraft is being done, given to the customer, we require a maintenance engineer to maintain it. Then reliability engineers are people who takes care of like how many components, what is their age group, how it is happening, whether I can improve the life cycle of it, whether I can depend on it or not to depend on it. All those things reliability engineers they take care of. Then technological specialist. Technological specialist is a person who develops softwares for smooth functioning and cloud computing, internet-based data, then artificial intelligence applications, robotics, 3D printing. So even latest technology which is available in the market, we need to identify and bring to the aircraft industry in order to reduce time and for smooth functioning and for better results. Then space engineers and scientists. As you are aware, ISRO, they take a lot of space engineers, as well as there are so many private industries. So space engineers and scientists. Then scientists and research associates at R&D centers like NAL, okay, and so many R&D centers are there like CPRI, okay, CSIR, activity NAL. So they are also required as a scientist and research associate. Then marketing and sales. Many people might not have thought that marketing and sales is also there as a career for aero engineers. Once a product is made, it required to be sold in the market. It required to be, put in the market and see that it is getting sold. Okay. So one example I will tell you. One of my student, I met him. He was there with me as apprenticeship trainee in HAL. After 1 year, I was there in structures group at that time. After 1 year, I met him. I asked him where you are working. He said to me, "Sir, I am working with one structure design-based company." Okay, fine. Later, after a year, I met him. I asked, "How is your job?" He said, "No, sir, I resigned." I asked, "Why? What happened? Are you not feeling design as a promising job?" Then he said, "No, sir, I am into sales now." Then I felt bad. You are a very good student and you are involved in design and structural analysis. What made you to go for sales? Then he said, "Sir, I am with Bombardier now and I am taking care of lease as well as sale as well as contracts for Bombardier aircraft. And that's how I am working." Then I asked, "What is your salary?" He said, 40K I am drawing. Okay, I said, "Okay, very good, fine." Then he said, sir, the salary is not a matter to me, even I will work for free. Then I thought he's a passionate. I asked, why? What made you? Then he said, sir, whatever deal I do, 1% of the deal comes to me. So fantastic life. If he is is capable to MOU or lease it for so value, it will be in crores, right? 1% of it is so huge. Then immediately ask, is there any vacancy for me? So that is the kind of vacancies available for people. You should be open enough. Okay. Then certifying specialists. Nowadays, certifying specialists also there. Whatever the component you do, it should be either DGCA certified or either Similac certified. So there are so many certifying agents also. But so you can work along with them as well. So these are different areas. Okay, I am sure that minimum 50% of it you may not be aware. You will be always looking for the terms which you already know, rather than browsing and getting the appropriate data. What kind of industries can be there? The industries are defense services, Army, Air Force, Navy, Coast Guard, DRDO. Then civil aviation, you are aware. Why? Because you may feel that you want to become a maintenance engineer. So the people who are having interest in maintenance engineer, they can have an interaction with me. I will tell you, your course is towards aircraft design. It is in more or less like 70% aircraft design. Some knowledge is given to you, because unless you don't know the maintenance basics, you cannot involve in design. Unless doesn't know the manufacturing basics, you cannot design the component. That's why it has been introduced. If you are so interested, you have to do AME course. That is again separately entire different field. Okay. So civil aviation, even Air India and Indian Airlines, they take BE aeronautical engineers. Okay, civil aviation. Then military and defense systems, space agencies, industrial production area, software technology, avionics, power plant. In India, there is a wide scope for power plant design and development. Still, we have not achieved competent enough aircraft engines. When I'm talking power plant, it's both for aircraft as well as for the industrial, or as well as for the marine industry. Drones, according to drones, sir had told you and given very good information. So drones, you might have got no very good idea. High-speed systems, rotables, like anything, any sports cars or any wind turbines or any high-speed rotables, it involves aerodynamics and propulsion concepts sometimes. So that industry also, they want aeronautical engineers. Then technical publication. Technical publication is also one domain. Whatever work we do, we should develop proper bulletins. We should develop a proper documentation system in order to help both for the production as for the servicing and for maintenance of those aircrafts or systems. So for that, technical journals they prepare, bulletins they prepare, manuals they prepare, but they use a lot of softwares like Photoshop and Adobe. Okay, but technologies with the aircraft technology, but most of them working on the Photoshop and Adobe kind of softwares. There are also many aircraft engineering students are there. Nowadays they are doing even CATIA and CAD also, in order to bring the design layouts into technical publications. Okay, then aero product sales and services, already I had mentioned. So these are different kind of, again, industry domains where aero engineers can think of. Okay, opportunity for being an aeronautical engineer. Once you say, sir, I'm an aeronautical engineer, nobody is taking freshers. I will tell you, you should look for graduate apprenticeship training. All HAL, NAL, DRDO, government labs, everybody, they take apprenticeship trainees during the month of September, October. Okay, and what they do is they will call for an open advertisement in their website as well as in the paper. You need to apply. You should have minimum some 70% score and some stipend. And some companies are paying 7,000, and they will give 1 year opportunity to you to be in HAL or NAL and to learn things, so that once you are going out, you can say you have a 1 year experience. So this is a wonderful opportunity. But again, who and all are applying? All will not get. So you should be competitive enough. You should be able to maintain your percentages. That is very important. Okay. Then nowadays private companies also taking graduate apprenticeship training. Then Government of India training, senior and junior level. Government of India training. It's an again kind of apprenticeship training only. They are taking at senior and junior level. Contract engineers. There are a lot of contract engineer opportunities. Like normally, once you are finishing your BE, BTech, aeronautical engineering or aerospace, HLNL, DRDO sometimes they take you for some projects on contract base. Contract can be for 1 year or 2 years. They will pay you 10 to 12,000 rupees as an monthly salary. And later, once you are establishing yourself, it can always grow. So, contract engineers also is an opportunity. Then, JRF, junior research fellow and senior research fellow. These two nowadays through interview or through NED or through GATE. Their national entrance test they are conducting or through GATE score they are taking. So GATE become one of the important factor here. So you can go into companies as a JRF, even IITs, NITs, they recruit junior research fellow. Later you will be promoted as SRF, senior research fellow. Okay. Then HAL, NAL, DRDO, ADA, ISRO, these are the organizations who take all these engineers. Okay. Yeah, opportunities in India. Dear friends, there are so many companies. Earlier also I had mentioned so many names. These are few companies which I am listing. If you can go in Google, you may find so many companies data. So according to me, there are nearly some 300 MSME companies exist today. Nearly some 30 to 40 MNCs exist today. And there are so many government organizations exist today in India. Few names I had mentioned. That is ADA, Aeronautical Development Establishment, DRDO, then Hindustan Aeronautics Limited. Many of you may not be knowing, even Godrej and Boas, who makes birwas, lockers and all those things. They are also into aerospace. And a few of the airlines are Air India, Boeing, then Axis, IT and T Limited, then BrahMos, then Honeywell Aerospace, BAE Systems, GE Aviation, Mahindra Aerospace. These are few companies here. Few global opportunities. Okay, aircraft manufacturers, you can see Boeing, Airbus, Lockheed Martin, Cessna. Engine manufacturers, GE, Pratt & Whitney, Rolls-Royce. Helicopter manufacturers, NASA is there. Power systems, then airline industries. These are foreign-based, few names. Some technical publication companies, Lionbridge, P3OH, Studec, Infotech, Saffron, Capgemini, they are all into even which and all big companies like Boeing, Saffron, Airbus, they too are into technical publication. They too have clients for developing technical publication literature for them. And Infosys, Infotech, TCS, Wipro, they all into technical publications. Okay. Okay. Normally, you may get a doubt as a fresher when I'm getting a job, what I'm going to do, whether I'm going to develop a missile. No, kindly understand. Being a fresher, your usual job will be you will be getting some training or working under supervision of some experienced engineers. Your real-time industrial learning starts there. Like your engineering 4 years, there also industry require minimum 3 to 4 years for you to be very individually independent enough, capable enough to do the things. Until then, you will be working along with the experienced people as a juniors. If you get recruited in HAL, you will be getting recruited as a design trainee, management trainee. 1 year training will be there. After that, you will be recruited as grade 2 engineer. After that, you will be promoted as deputy manager, later manager, then senior manager, then chief manager, then deputy general manager. So these are the stages for over 4 years. So when you are going for a company, no company will expect that come and do a drone. Nobody will expect. But what they expect is when they are having a drone project, when they are putting you into that, whether you have strong enough basics, whether you have strong enough academic background, capable enough to understand the technology and apply your academic background to this, and get into projects, understand it, do some small solutions, at least follow the process, at least supervise the process. So whether you have that knowledge, that's what a company sees. Here I am sure that many of the students will say, மச்சான் எனக்கெல்லாம் வந்து படிக்கணும்னா ஆகாது, I will really work on something, hardware. If you say something, I will make it, but studying this matrix and all those things, no, I am not interested. Look, since you are engineer, they are teaching you. If you are a 10th class fellow, they will not teach you. They will directly put it to lathe and ask you to work. Okay, direct in the hardware you can work. Okay, and while working in the hardware also, you will not be having a knowledge what you are working. Somebody will tell you, okay, do like this, you will do like this. Okay, unless you have a strong basics concepts knowledge, what is aerodynamics, what is propulsion, what is thermodynamics, what is gas dynamics, how they do, what is structures, what is this beam theory, what is that cantilever beam, how it operates. Unless you read all those things, a real-time application is very difficult for you. Even when you go into a company, even they give you some project to you, you have to start from this. Unless you don't know aerodynamic concept, how you will arrive to a product? You cannot arrive. So your knowledge, your mathematical knowledge and your science knowledge is very, very important to get into a promising job field. Once you get also these things, again and again you have to read, unless it is not useful to you. You may be seeing, a lawyer is there. A lawyer, he had finished his course, he had to go to a court, he had to contest for a case. What he will do? He'll come back and refer books. He will see what amendment, which law, what page, what it says. Unless you do this, you will not be able to succeed. Okay, then some of the learning come job execution process. It is continuous, you have to learn and do. And new engineers gain knowledge and experience. You should gain knowledge and experience. So what I'm trying to say is, don't aim too much. For example, one project batch came to me. They said that, sir, I want to design a new product. Sir, I am audible now? What I am talking?
Yes, sir. You're audible, sir.
Yeah. So told me they want to design and develop a new product. I said, okay, what it is? Sir, my innovation is that an amphibian aircraft, it should go on the ground like a automotive car, then it has to take off, then it has to soar in the sky, then it has to come into water, and underwater it has to go like a submarine. Okay, fine, I understand. Then I asked, okay, so how you are going to do? Then they asked, sir, you guide me how I have to do. Then I asked, what is your role in this? He said, no, that is my thought. It's an innovation thought. Come on, it is a daydream. Thinking, dreaming is not a thought. Thinking and telling that this is my idea is not an idea. You have to implement it. There should be documentation. There should be a supportive exercise to say that yes, this idea is applicable. Okay, and such a kind of concept, when you are talking where India is struggling to make fighter jets which can go up to Mach number 1, and you are talking about some very innovative technology which may require after 30 years. So what is the use? You have to understand first what is the current job role. For example, gas turbine, there are no engines. Their design and development is going on from past 40 years. You have to be part of it. You have to learn from it. You have to be, get your career in this. Rather than you coming and talking, I want to develop a hypersonic engine like that. It is not possible. When hundreds of engineers are working on some ramjet, turbo jet engine, and they are trying to succeed in India, you are talking about a hypersonic engine. You have no job role here. Yeah, it can be in the research paper. Okay, but those research papers also should be meant with the technical data, with experimental analysis data. Otherwise, it may result in merely a daydream. So I want to say you that your job is to learn good your 4 years and to implement it and practically implement and learn the things. Okay. Okay. Air engineers career planning. We'll get into this. Have you really they took nearly 1899 to 1905 to test try the program. They took nearly, almost like 16 years to keep on design it, to keep on, modify those aircraft design and to, fly it practically. So when 1899 means what? Before that, they are well enough with the idea. Before that, they are well enough with their plan. Before that, they are well enough with their finance to start this project. Once they are starting, it took for them nearly this many years. And they are lucky enough. There are so many engineers and scientists way back from centuries to centuries. They had put their life behind developing one product, and even they died in the accidents. Okay, so any product design and development is not an easy task. You cannot think that I will start in the final year during project and do within 2 months. No, it is not. It should be a long-term process, and it should be a data collected, activity. So that's how I say. So for you, 4 years of engineering consists of 48 months is a career journey. The moment you joined aeronautical engineer, then itself your career already started. Here you don't have time to waste, and you don't have time to keep on writing your arrears or waiting for holidays and bunking the college. You don't have time. Why? Because you're competing with a kind of people. Once you are slow enough, they will overtake you. Mechanical engineering will overtake, electronics will overtake. So you are already into a kind of roller coaster, competitive roller coaster. So a good preparation is always required for a career path. And one more important thing is that whenever we talk about job or career opportunity, it is not a responsibility of the college. My fundamental principle is that your job responsibility is not with college. College responsibility to give you good education and skills only. It is the student responsibility to choose his area of interest, to prepare for it, and to select a good job. What happens? Some of the students, their parents, they put the pressure on the department. So what they will do? They will bring any tech pub company or any company for a placement. So they will not do purposefully, but whatever opportunity available, they will bring it. So at that time, you have to get compromised with your area of interest. So first you have to choose your area of interest. Then accordingly, you have to search in a broader way so that you can get into a better MNC. So kindly don't put that pressure into your staff. You can put a pressure to get a lot of knowledge and skills awareness. Okay, I will tell you what you need to do for a career planning. I already mentioned what are all the projects available in India. I already mentioned so many domains are there, and even I told you that being a fresher, what you do. But being 4 years also, you should do something. Unless it just goes on. According to me, aeronautical engineering or any engineering, it is a combination of course as well as skills. It is kind of 50-50%. Okay, if somebody is only concentrating on course and he scores 90%, it is for 50% of the outside requirement you had scored 90 marks, 90% marks. The another 50% is skilling up yourself. Then again it comes, many people day after tomorrow they will go for production, day after tomorrow they will go for electronics. Then at the end you end up where? You get knowledge about everything, basic knowledge about everything. You have to choose a field. In that field, you have to progressively study, progressively build your interest. And later, it should be something like either you're going for a job in that field or either you're opening up a startup. Otherwise, what happened? You will learn 100 technologies and you are a no man, nowhere. So it should not also happen. You should be very selective in what you are doing and how it will lead to a career path. That planning should be there. Okay. So, sir, how much time I had left?
But you can continue, sir, no problem. You can continue.
Okay, thank you.
Because you're answering the biggest question that we are facing in day-to-day life. Being a faculty, yes. So you can continue.
Yes. And I love if students ask me more questions. I am here to answer them. Okay. So 4 years career plan, what you should do? That I will tell what you should do. So once you are joining an engineering, day one itself, you should have an idea what I am joining. Somebody will say at the final year, Macha, flight training solli kudukranga nenchen, nan join பண்ணிட்டேன். எனக்கு யார் சொன்னாங்க ஃபிளைட் ட்ரைனிங் சொல்லி கொடுக்குறாங்கட்டு? இல்ல இருக்கும் நான் நினைச்சேன். No, it is not the thing. நீ நினைச்சா ஆவாது. What is there you should know first. So what is aeronautical engineering you should know first, and importance of your engineering and opportunities. Okay, where and all opportunities are there, where applications are there. And through Aero Society, every year I organize students public notice. It is open for all. At that time, when the notice comes, you have to fill the application, pay whatever fees, apply for a written test. Nowadays, they want gate score. So this is how you will go. For private companies, you have to refer Freshers World, Naukri.com, and even you can have a list of companies with you. See their websites. Whenever they are posting some job requirement, send your resume to the HR mail ID. Even through LinkedIn, you can post your resume. LinkedIn is a great source for recruitment. In LinkedIn, you see there are so many, companies are there. They put their vacancies, so you can apply through this. This is how you can.
Yes, sir. Thank you, sir. Students, if you have any question, you can put it in the chat box.
Okay, I have something to say, sir, for the department.
Yes, sir.
Department normally, how I feel is department should have a mentor group or industry relations group. Okay, that's how you can connect, like Srinivasan sir or seniors or anybody. They should be available on some honorarium based or salary based, or they should be available in order to guide students to bring the outside market industrial knowledge inside the college, inside the department. And whenever we say there is for example, now I came to learn that you are establishing a center of excellence for drones. Excellent, thinking. But that center of excellence should not serve the purpose of doing aero modeling workshop. It should satisfy a purpose of doing some robust or doing some really industry based application based drones. So the infrastructure or the guidance or the students involvement, it should be at the high at the industrial part level. And I can support in bringing all the industry resources and funds or industry experts to your institution. Even my idea is we should have a center of excellence for aircraft manufacturing, where we can put some lathe machines and some machinery, and there in total Coimbatore we can take some industrial projects regarding for aerospace. Even we can supply for HAL, NAL, and that's how we can even clear the way for student placements. Our own students can work as an interns in our center of excellence, and it can move on. That's how it can reduce the risk of placement drives as well as career this one problems. So we should focus more towards manufacturing, like aircraft manufacturing, drone manufacturing, propulsion manufacturing. So our ideas should be like this.
Sir, sure, sir. Sure. We are actually on the process of connecting with the industries, different industries, because we understood there is a lot of difference between.
We created one center of excellence in Nehru College, sir. They came into paper and everywhere. Later they are closed. What is the use? Like, for example, somebody created a center of excellence for space technologies, they are saying, and they are just to give a workshop for students and merely earn some money. That how it will not be helpful for students in any way. There should be a progressive planning. Like if center of excellence for space, later stage there should be some career programs. Later stage they should go for internships in this area. Later stage they should be able to start up. They should be able to start a company. That's how that center of excellence or incubation center will fulfill the real meaning.
Yes, sir. We need to have a functional kind center of excellence.
Functional idea.
Yes, sir. Yes. So thank you, sir. There is a question. If sir, if private companies to be approached for a job can be directly approached them.
We need not approach directly. We cannot go directly. Through net only we can approach. Please have a list of companies, their websites you see, and when there is a vacancy or no vacancy, also to their HRs you forward the resume. Through LinkedIn you will become to know about vacancies, and through news, as I said, For government jobs, you will come to know about vacancies. And you should have a very good network of your seniors who are passed out. Through LinkedIn or through social media, you should have your alumni association or alumni network. Then they can pass on the information. For example, I'm working in Capgemini. I can tell that Capgemini is recruiting. So, like this way, he can help. So, being good with seniors is a really a kind of boon. Really kind of a divine thing. Being good with seniors. So, you should have in seniors, juniors a good relation. They will pass out. They go and work somewhere. They will pass on the information to you. And Aeronaut, you will see Aeronaut. Nowadays, we are publishing whichever job vacancies or industrial knowledge, everything in Aeronaut. The www.theaeronaut.in. There also, you can find a lot of information. Directly, you cannot go. Companies will not allow you.
Thank you, sir. Sir, I think, shall we wind up the session, sir?
Yes, sir.
Okay. So I call upon Ms. Sharushri, third year aeronautical, to
Yes. Thank you very much, sir.
To give the vote of thanks. Sir, I call upon Ms. Sharushri to give the vote of thanks.
Sir, am I audible, sir?
Yes, ma. You can go ahead. Yes.
I, on behalf of the Department of Aeronautical Engineering
Yes.
Celebration Committee and the entire members of the department, let me call it fraternity of the people here together, and on my own behalf, extend a very hearty vote of thanks for gracing your important work and sharing with us your opinions. I like to express a sincere thanks to Dr. K.V. Srinivasan, retired emeritus scientist from DRDO Bangalore, for spending his quality time with us and sharing with us some very useful information on UAVs and MAVs. Thank you, sir. I also wish to express my gratitude to Mr. Moeen Ahmadullah Khan from HAL Bangalore for his gracious presence and for giving us some valuable information about various opportunities in aviation industry. It was very helpful. Thank you, sir. Finally, I would take this opportunity to place on record a hearty thanks to our HOD, Mr. V.T. Gopinathan, for always inspiring us in different ways to learn more. Thank you, sir. We have been fortunate enough to be backed up by a team of motivated and dedicated professors and assistant professors of the Department of Aeronautical Engineering who know their job and are result oriented. You never fail to astonish us. Thanks to your efforts, that we are able to organize things smoothly. I also thank our management, our CEO Dr. Karunakaran, and our Dean Dr. Magdishwaran for guiding and motivating us all the time by creating such useful platform for us. Thank you, sir. At last, I thank you for giving me this wonderful opportunity and this privilege. Thank you.
Thank you. So thank you, sir. Thank you to Dr. K.V. Srinivasan, sir, who's
Thank you very much,
on the
sir.
call.
I'm
Thank you,
signing
sir.
off. Thank you.
Yes, sir. Thank you so much, sir. Yes. Students, kindly wait for 2 minutes. You have an information, so kindly wait for 2 minutes. Tamalvendan sir, are you available, sir? Tamalvendan sir.
Yeah. Thank you, sir. I'm available. So I don't want to take much of your time. Already it's lunch time. It's my pleasure to be here on a very auspicious occasion. The birth of aerospace personality, people's president or former president, Dr. APJ Abdul. And the program as well, we are very happy about it. So on this occasion, I used to give some detailed information about.
Sorry to interrupt.
Yes.
It is not audible.
It's not audible?
Yes, sir, it is.
Okay. What about now? It's still breaking or?
No.
Okay. So, what are some During this period, like some past few weeks, we are progressing in a different path. I mean, most required areas, as the chief guest, the guest speakers rightly said, industry, institution relations. So we are trying to spread our wings to establish a contact between the industry and institution in all possible ways. At the end of the day, the students will be benefited. So we are looking for center of excellence from various companies and training programs through the industry persons, implementing the industry-oriented skills to the students. So part of this activity, we would like to start a chapter, local chapter for a very famous space club owned by VIT, called as SEDS, SCDS, Students for the Exploration and Development of Space. It's called as SEDS, SCDS. We don't have a local chapter over here. Only I think the Kumaraguru College of Technology have the local chapter for Space Club. They are through that club. They are conducting various events like workshops, and the students from the states, they are participating in various national and international level projects related to space and aerospace vehicles, design, execution, everything. So we have a plan to establish a local chapter for that students for the exploration and development of space. So in this regard, we have approached the central command, and they have given some requirements. So among those, the very important requirements to initiate the program is to establish the executive committee, which consists only the student members. So we would like to elect the student members for the executive committee as well as for the board of members. So in the upcoming days, the details, the notifications will be shared to you through your class advisors and other professors in the WhatsApp group. But still, this is the simple information, or small information. So those who would like to be the part of the SETS club, the students for the exploration and development of space, SETS. So those who are really interested in space activities, space vehicles, more or less like aerospace, the vehicles which operate outside the atmosphere. So you are most welcome. We are looking for a president, a vice president, treasurer, event manager, event head, project head. So all these posts will be, all these details will be posted as soon as possible. So those who are willing to join the club, you may give your name. You may nominate yourself for all these posts. If required, there will be the selection procedure by the department committee. And along with that, there should be at least 15 members, active student members in the group to initiate the program to start the